Some of these things that are hardware related, we're going to cover, and the software related, not day 2 operation is what we're also going to cover. Day 3, like support a package, there's a package that the client might decide to take after the install is done, and then we will be able to monitor this, or the third party can be able to monitor this and tell them when their light's not working, they can't see it, it's not pingable, somebody's trying to hack into their system and turn the lights on and off. This screen is what we saw in the beginning of the training, and I like to go back to it just to visually we can understand how the system is wired, because that's important. Network topology is very crucial when you're dealing with a troubleshooter. If I'm trying to troubleshoot a system, I need to know how it's wired. I need to understand the capability of the system, what it's supposed to do and don't. Why is the light flashing? And some of the protocols we already saw that if you assign too much wattage to a driver, the light will flicker. And we saw that already in the lab. If you do not assign the right policy to your room, you might be assigning it to a different room. If you can't find your device, you won't be able to do any of this. On the left-hand side, we saw that if the light fixture is integrated, it's pretty easy to troubleshoot. If the light's not working, it's one fixture. Right next to it, if the light fixture is an L18 for Pure Village, for example, you have multiple of these. And you're going to try to troubleshoot, is it a single light or is it multiple lights that are having a problem? That determines the amount of troubleshooting you need to do. If I look at the ceiling, and let's say it was the L18, and the L18 is 4 or 3 today? 4 per node?
4 and 3.
Okay. Let's say it was a 4 nodes, 4 L18s are off. Automatically I'm troubleshooting. I know that this is not a light problem, it's the node problem. But if it was one single node that's off, it's a single light problem. So understanding where things are connected is very crucial. That's why knowing the field where you're going to is very important. Second important parameter is the pull schedule. Understanding where every wire is connected to is also important. You need that as-build, you need that pull schedule in your hand to identify, okay, here's the light, here's why it's not working, but look at the IT closet and how many wires is in it. How can I troubleshoot that without an actual pull schedule? So labeling every wire is very important. There's 5 issues that we can possibly identify today, and we will have 5 different answers for each one of them. Number 1 is, if the light is flashing, what went wrong? Why is the light flashing? There's 2 types of flashing. Is the light flashing continuously, or is it just flashing once a while? That makes a big difference. If it's light flashing continuously, that meaning it's flickering, that means it's getting too much power or less power. And that's a configuration issue. So we would go back to the system, and I'll give you a perfect example. If I give 4 watt to, I'll do the other way. If I give 15 watts to a 10 watt light, it's going to light, it's not going to burn. What's going to happen is if you dim it down to 50%, you'll see the light doing like this, flickering. And one of the problems that you'll see is that you're pushing too much wattage into that particular light, therefore it flickers. That's why the amount of wattage that you deliver at every driver is crucial. If it flashes continuously, it's because of that negotiation problem. You have maybe 1 or 2 lights connected, you're pushing 40 watts into 2 downlights, 2 small hi-hats, and they can't handle that power. So they continuously turn on, try to grant power, turn off, turn on, turn off, and you'll see the light strobing, on, off, on, off. If the light is completely off, the client calls or you're doing the install and you're like, why is this light not even on? Simple reason is every light when it's plugged in, if the switch is not pressed, if the policy is not active, the light will remain off. So that's important. If the light is off, is for one reason only, it should be only because if it's day 1, you first plugged it in, it turns off automatically. You need to press something either from the inspeXtor mobile control or from the wall switch in order for you to turn it on. It doesn't turn on its own.
Well, the switch always overrides what it's programmed?
Yes. The switch always overrides anything that's happening. Policy, override, any of that, you just press the wall switch. If that wall switch is commissioned properly, it would actually activate. One thing to keep in mind is if that wall switch, one of the reasons why the light can actually be off is, let's say I'm doing 2 rooms back to back, and by mistake I took this wall switch not knowing, and I put it into that room. I can't constantly keep pressing and the light is not even going on or off. But there's multiple things that are going on when the light is off. One of them is whether or not the actual node is on, is even connected. If this thing is not connected, of course the light is going to be off. And you'll be surprised how many times we find out that this thing is not all the way. It has to snap. If it doesn't snap,
Sometimes if the pin is broken,
it doesn't make a connection. If the pin is broken, I would hope that the termination gets done again. But you're right. If it's not all the way in, if the pin is broken, if it's broken, it will go in. The pin is broken, it will go in. It just it won't make connection. And if it's half in, because maybe it's short, maybe it just got thrown far away after you're done and you're on the ladder, you just shove it down, it gets unplugged, and then it's halfway there, you'll see the light that's not connected. There's ways to troubleshoot that, because one first thing that I'm going to look for is, I know where it lands, I'm going to go check on the switch to see if it's green. If it's green, that means it's making connectivity. If the wall switch is not responding. All our wall switches have status LED, which is on the top left corner for this model. So, and I think this is the only model that you guys will see. This LED will flash every 10 seconds, once every 10 seconds. So if these things have power, all you have to do is wait for a little bit and you'll see the light flashes. If the LED flashes green, that means it's receiving power. If it's receiving power, it's a software problem. If this thing is not even flashing, it might not even be plugged in the back, or maybe it's hanging somewhere in the ceiling. It's not even plugged into the control side. Sometimes you would think that it's plugged in from this here on the wall, but the other end is not plugged in anyway. If the PSC is disabled, PSC is power source. If it's disabled, that means one simple thing is, if somebody pulls the 110 out of that whole switch, the switch will go down. Everything is going to be off. So it's critical to understand the issue before actually making the move. Sometimes the issue can be in one area, and you're down the road trying to troubleshoot other stuff. That's why it's very important. When we get a ticket, we want it to make sure that it's very specified. When a customer calls and says 24 of my lights are off, I'm like, oh, thank God. Why? Because there's 24 ports on the switch. That means the switch is unplugged.
Yeah.
If someone calls me and says one light is off, okay, that's harder to troubleshoot.
Yeah.
8 ports are off, or 8 lights are off, or 8 nodes are off, easy. I don't have to go to the light. I'll go to the wall switch, make sure there's 110 before I even go to the nodes or lights or anything like that. Or the switch maybe sometimes needs to be rebooted, just like your phone sometimes gets stuck and it has to be rebooted. But we'll get to that later. If the policy is not working, and we've saw some cases where you can either do it backwards, you think you're in the right time zone and you do a policy an hour before or 4 hours before, or
Click the wrong time.
or if you click the wrong time. Things like that happen. So if a policy doesn't kick in, usually it's due to software, because it's software driven. If you're assigning a policy and you're waiting for it to kick in and it doesn't happen, just please go back and read your policy. Make sure that you're actually applying what you want. It's sometimes as simple as not using the right, if let's say a client wants Monday and Friday and you click Monday and Thursday and you think you did Friday, you won't be able to see it easily because you think you did it, but you actually clicked the wrong day. So things like troubleshooting policies are easily addressable because you can do it remotely, you can log into the software, it's pretty understood. Things like a light off can be very, very time consuming. You might have to go to a ceiling to find out why this thing is not even plugged in or connected. But what we're going to do is we're going to try to avoid that. Assuming that the contractor does what he's supposed to do and plug this thing in, we're going to try to do as much as we can remotely. Even though when you're commissioning the site and you're trying to troubleshoot, we're going to try to do everything off, not being in the ceiling, not being on a ladder, not going to the IDF closet. And I'm going to show you some of the examples where we actually won't touch anything. From a PC, we'll be able to troubleshoot all the way down to the light. So the first step is we're trying to troubleshoot a PSE. If the light is not working and it's multiple lights, not just one, most likely it's this guy. It's either the 24 ports or 8 ports. All you have to do is reboot it. You don't have to reboot these things, not even once a day, not once a month, not once a year. There's no formula of, oh, it's not working, just reboot it. You have to get to a conclusion where you could say, I think it's not working, I'm going to reboot it. And to the left of these device, the Cisco devices, either 3850 or CDB, they have a status link. And the status link, if it's not blinking, that means the actual software in there is stuck. And that's when you pull the plug. But that's after the fact that you identify it's not just one port and I'm pulling the plug on the whole switch. It's multiple ports, and I know it's dead, therefore I should be able to just unplug it. Again, light is not working. First thing I'm doing, I'm verifying the physical connection. And I'm verifying the physical connection from the fixture all the way down to the switch. This simply means that you can come on either side of the spectrum. You can go from the fixture down to the switch, or from the switch down to the fixture. You ran the cable, you patched it. You don't have to recheck every single patch, meaning that I don't have to go to the patch panel, or I don't have to go to the end of the wire. I'm going to go from the fixture to the yellow wire. So you see the fixture is on the left and the yellow wire on the right. I'm only going to check that connection. I don't have to check the entire thing. That's understood? Because that saves a lot of time.
And this assumes that you have the pull schedule and that
So I was gonna say next.
that everything's labeled.
You're supposed to test the cable before you do the install.
Right. Let's say assume you did test it and it did came out okay, but
It's still not working.
that small little patch cord you can't test for. You're testing from the patch panel from the right-hand side all the way to the fixture. But that small patch cord, it's 6-inch. I mean, you're not going to test every one of them. They come pre-cut.
Yeah.
But one of them is not good, and that's the one that's causing you a headache. Easily to just take it off and test that on the fly. But the idea is I would test from the one side of where the yellow cable is all the way to the fixture. So if I know that's good, I'm not testing anything in between. There's no point. I don't have to divide the problem, because it's either on the fixture side or on the switch side. It can't be anywhere in between. And simply, how do you check when there's a fixture not working and you know that it's not the switch, it's actually the fixture? You think it's the fixture. Simple things to do is grab one of these guys. They plug themselves into a 110. So you find yourself the closest 110. The fixture is in the ceiling, and this comes back to, if this was a high voltage, do you expect the electrician to bring a multimeter, or does the job supply it? It's the same thing. It's your own multimeter for PoE. Like Vince mentioned, they're fairly inexpensive. I think they're $20 or under.
Yeah, but can I buy this
Amazon.
on Amazon? Okay.
Amazon 2 days comes in $20 or less. So
I didn't know I could buy this or not.
yeah.
That's
It's a standard PoE injector. Nothing different. The only thing that you're verifying is you're eliminating all from the Cisco switch all the way to the light. I'm going directly to the light and saying, okay, look, it's powered. The fixture is okay. The node is lighting up. The problem is not here. I got to be over there.
Okay.
But that connects to the node itself, right? Not the fixture.
Yeah, well, if the fixture has this in it,
Yeah.
then you plug in here.
Yeah, exactly. But only for that connector specifically, for the PoE one.
Yes,
Okay.
it's only for the PoE connection.
Unless it's an internal fixture.
If it's an internal, it's going to have only PoE anyway.
Yeah, exactly.
So you're going to plug into that.
Okay.
Or maybe it'd have PoE and controls, but you'll plug into the PoE side. So what you'll be able to do is we want to eliminate the cable that ran from the fixture all the way to the switch. We want to just test the node itself or the fixture to make sure that that's okay. And we're going to cover how do you know that this thing is actually on. When you plug it in, what light's supposed to turn on, what behavior you're supposed to see. And if you see this flash, that means this. There's a troubleshooting book, so I don't expect you guys to remember that, but you can go in there in the software and it tells you, okay, if this flash happens, this is what it means. If this flash happens, this is what it means. Testing the cable. To look at the patch panel side and retest the cable. My experience, if you do it once and you do it right, you don't have to test the cable again, and it won't move. Yeah, if you don't touch it, nothing happens. If you push it against the wall, got crimped, or in some cases you might have animals in the ceiling that actually chew it.
Yeah.
And you think, yeah, both ends look okay, but the cable in between got chewed up, and it's not making a connection. One element to check for is the inspector. If the light's not working, make sure your inspector is not pushing a policy for that time. So if there's a policy on a Sunday to keep the lights off, and you're coming on a Sunday try to check for why the light is off, chances are it is already off. So you can check the ports in the schedule. You can check the ports to find out if a port is active or not active. There's 3 colors identifiers to the Cisco switch that we can actually pull out of every switch. So we'll be able, or inspector will be able to show you if there's an actual connection between the node and the switch, the port will be green. If the cable is unplugged or the node is dead, but it's not pulling power, that means it's completely dead. This device is probably bad. Somebody dropped it from a 3-story building. It will be red. If you physically unplug it, it will be red. There's a gray port, and that's important. If the port is gray, that means the port on the switch is faulty. So it's not a node problem, it's the switch problem. Chances are, sometimes that happens if, let's say the node tried to negotiate power, and I'll take the case where you had 3 downlights, 3 hi-hats, and you pushed 40 watts out of them. The port will grant you power the first time to this node, and then say, okay, go ahead, turn the lights on. Nah, too much. Okay, try it again. It does it, I think, 10 or 15 times, and it shuts the port physically down for maybe 24 hours, sometimes even longer. So that port will have to be, through an admin, you log into that port and you administratively revive it. And sometimes if you're doing a bigger job site, you do this, a light is flashing somewhere down the hall, you didn't even pay attention, you try to come back, it's off. You do all this troubleshooting, find out that it's the port that's faulty because it timed out, it was pushing too much power or pulling too much power. So check the port remotely if you can, or through the GUI, it gives you much faster response than going in the ceiling, finding out that this thing is okay, retest the cable, coming back to the switch and find out, oh, it's just pulled too much power. The one last thing I want to comment on the inspeXtor GUI that shows the power settings, it's doing it once every 3 to 5 minutes. So look at the time step on the right-hand side. So this switch is switch 4, this switch is switch 5. So if you are on the right switch, click on the switch that you're looking for. And on the right-hand side, you'll see the date and the time. That's the last updated on. If that time doesn't match your clock, your current clock, you're looking at data from, let's say, an hour ago, 2 hours ago, and the switch never updates. So don't take that for granted that you're looking at the switch. Make sure you pay attention to the time. You're not looking at yesterday's status.
Just so that we know, there's a power supply that goes on the back of the switch. There's actually 2, if it's a 24 port. That can be removed live, right?
Unplugged, then it removed.
Unplugged and removed, and then put back in without a major issue. I mean, one of the things that, for a project like Millville or a project like Pier Village, you're going to want to have attic stock of certain things. Not a ton, but like a couple of fixtures, a couple, power supply, and that way,
A couple of these.
nodes. That way,
Splitters.
things can be swapped very easily, very quickly, without too much commotion. Power supplies especially, because if we've got to order it from Tech Data,
90 days
90.
before you get a power supply.
could be a while. So,
Yeah.
but it's very user friendly in swapping out.
Yeah, so the idea is, in a project like Pier Village, you have a CDB, which is an 8-port switch. That doesn't have modular power supply. So if that thing is dead, doesn't function anymore, you have to take the physical device out and put a new one in. And they're fairly small, they're not big. And if we do a tour downstairs, I'll be able to show it. The 24 ports, they have 2 modular power supplies in the back. It's like a power supply out of a laptop. You'll be able to unplug it out of the wall, take out the power supply and shove a new one in case if it fails, fan blows out, or any of that nature. It's just like a circuit breaker pops, circuit breaker's no good, I gotta take it, put a new one in. Or I should have used the fusible disconnect analogy. Fuse got blown, I take a fuse out and put a new one in. Same exact module. The reason why you want to do this, let me backtrack a little bit. In the 24 ports, you can data stack and power stack. What does that even mean? What it means is, if I have multiple switches, I have the ability to data stack them. That means if I have 5 switches or 6 switches like this, the one on the display, I'll be able to put them all in virtually one single switch. So I can manage that switch from an IT standpoint or from a troubleshooter standpoint as one switch. I don't have to physically log to every single one. I can log to one single switch virtually, and it shows me all the ports and their status. From a power perspective, I can power stack these 24 ports. What does that mean is it allows you to shift power accordingly if there's a power failure. So let's assume there's 2, let's use the scenario of 2. You have 2 switches, you have 4 power supplies potentially. If one loses its power, and hopefully it's a secondary power supply, you'll be able to shift the 3 remaining power supplies power as a budget and distribute it across the ports. Is everybody following that? So you can, if you have enough ports, you'll see the lights dim because one power supply got shot or it's no good. You'll be able to take that and replace it and put a new one, but at the same time you're not affecting the entire building where you're shutting the entire power off. One other question we get is, how long does it take when I plug this device in until I actually see power? For first timers, expect about 5 minutes, but once this device is commissioned and properly set, it's 30 seconds. You take it off, put it back on, it gives you power in 30 seconds. But the first time, when you first power it up, ever, it takes 5 minutes. So if you're doing it in the field, when you plug it in, it's going to take, if it's pre-commissioned, then it takes 30 seconds. If it's not commissioned, it'll take 5 minutes or most. The CDB, the small ones, they're much faster. And they're much efficient. So you can see power as fast as 25 seconds, even less, out to the node, out to the fixture.